Well, welcome back. Tonight we have a very exciting topic on calculating probabilities of events using a two-way frequency table. Now, you're definitely going to want a calculator handy. There's going to be quite a bit of adding and multiplying here. So what are we talking about? Well, the table that we're using is just a tool used to organize data. And this data will be organized into rows and columns. So this little scenario that we're describing, I don't think you need in your notebook, but you definitely need this table copied down. So you might want to pause it first and copy the table down. The school board of Waldo, a rural town in the Midwest, is considering building a new high school primarily founded by local taxes. They decide to interview eligible voters to determine if the school board should build a new high school facility to replace the current high school building. There's only one high school in town. Every registered voter in Waldo has interviewed. In addition to asking about support for a new high school, data on gender and age are also recorded. The data from these interviews are summarized below. Okay, so what do we have to get out? Basically, like we said, this table, this tool that we're using is going to be organized into rows and columns here. So columns and rows. Here we're describing the age in years. So this is just the age range from 18 to 25, 26 to 40, 41 to 65, 66 and older. The question is, should your town build a new high school? So the yes is broken up into male answers and female answers. The no as well into male and female answers. And then there's several people that just chose not to answer at all. So the first question, based on this survey, do you think the school board should recommend building a new high school? And explain your answer. So what are you going to get from this table? Do you think we should build a new high school or not? So I'm leaning towards looking at the yeses. If more people said yes than they said no, then of course I would build a new high school. However, if more people said no than yes, then we probably wouldn't build a new high school. So to me, what I'm saying is if I think they should build a high school, I'm going to need more yeses than nos. So what am I going to do? I'm going to add up all those yeses. Now, it doesn't matter whether they're male or female. I'm just looking for a yes or a no, basically. So let's see, that should give me a total of 273. Now, out of how many? To figure out of how many, I'm going to have to take everybody in here and add them together, whether they said yes, no, or didn't answer, because I need the total amount to find my probability. So remember, this is the probability that the event will happen out of the total amount. So again, I'm going to have to sit here and add up all those numbers, so grab that calculator, I'll do the same. Let's see, and I get a total, I'm just going to mark it off to the side here. You can double check me here. I get a total of 515. So I'm going to say, based on this survey, should they, well, let's see, that's 273 out of 515. So it's going to make more sense to me to grab that calculator, stick it in my answer, and I get 0.53, so 53% say we should build a new high school. So does that help me? Well, 53% is greater than half the people. So since that's greater than 50%, I'm going to say yes, we should build a new high school. Question 2. An eligible voter is picked at random. If this person is 21 years old, do you think he would indicate that the town should build a high school? Why or why not? All right, so the first thing I'm doing is I'm saying, okay, if I'm 21, I'm falling in this age range here. So if I randomly pick a person in that age range, do you think they should build a high school? Well, so I'm just going to compare the yeses. So if I just look in that age range, that looks like 61 people say yes. Out of how many? Well, how many people are in that whole age range? Let's see, if I add all those numbers up together, I would get a total of 75. So again, 61 divided by 75 is 0.813, so 81.3% would say to build a new high school. And again, since that's greater than 50%, I would say yes, they would want a new high school. And third, an eligible voter is picked at random. If this person is 55 years old, do you think they would indicate that the town should build a new high school? So notice they said 55, and that age falls between the 41 and 65-year-old bracket. So I'm just comparing my yeses in that section to my nos. And let's see, in the yes section, I would say that's 66, say yay, and nay, I would say 79. So in this case, I would say that the answer to this question is no. There were more no's than yeses, indicating that we should probably not build a high school. Okay, so this next table you already have in your notes, please don't recopy it down. Here's the important part. It might be helpful to organize the data in what we call a two-way frequency table. So let's make sure that's jotted down. Use the data to complete the following two-way frequency table. Note that the age categories are represented in the rows, and possible responses are represented in the columns. Okay, so does it really matter if you're male or female? Not really. We either want to build this want to build this new high school, or we don't. So the 18 to 25-year-olds, again, we don't care if you're male or female, we just want to know if you said yes or if you said no. So this table is very simple to fill in. Basically, how many yeses did I have? If I add those together, that looks like 61, versus how many no's did I have? I would say 14. People that didn't answer were 0, and if I add those together, I get a nice 75. The 26 to 40-year-olds, again, I don't care if you're male or female, I just want to know, do you want the new school or not? So it looks like a total of 113. Let's see, that looks like an 84, a 6, for a total of 203. Okay, you've got the idea. Why don't you pause it, fill in the rest of the table. Pause it. Alright, so we can compare, make sure our numbers match up. But again, I really just wanted to know either you want the school, or you don't, or you didn't answer. And then I'm just looking for a total. So our next little piece says, a local news service plans to write an article summarizing the survey results. 3 possible headlines for this article are provided. Okay, so think about a headline that you've read in the newspaper, or maybe online. Just because you read that headline doesn't mean it's actually true. Data can be very misleading. So you've got to be very on top of your game and investigate things when you read them. Don't take everything you read at face value. So these 3 headlines are possibilities. Waldo voters are likely to support building a new high school. Older voters are less likely to support building a new high school. Or younger voters are not interested in building a new high school. So is headline 1 true? Waldo voters are likely to support building a new high school? Well, let's take a look at the math. If I'm likely to support it, then I said yes. So all I'm going to do is I'm going to look at my yes total. So that's 273. Whoops, what am I writing? 273 out of my total amount, 515. So is that more than half? Well, if I divide that out, I get 0.530. So technically, 53% want to build a new high school. So since that's greater than 50, I would say yes, we're likely to support it. Now, was it by a landslide? Heck no. Only by an extra 3% there, so be real careful. Everybody really doesn't want it, but just a little more than half did. Headline 2. Older voters are less likely to support building a new high school. Now here's where it gets a little sketchy. Maybe you read that in the newspaper. Well, what does older mean to you? And what did it mean to the person who wrote this article? Does old mean, I don't know, you're over the age of 30? Does old mean you're over the age of 40? Over the age of 60? What does old mean? Okay, so just because you read this sentence doesn't actually mean, it may be true or false. We have to understand what the word old means. So let's say you think old is, 41 and older, 41 plus. Then I would have to consider everybody over the 41 line here and think about that. So let's say older voters are less likely. So that means they're saying no. So I'm going to pick everybody that said no over the age of 41. So I'm going to say that's 79 plus 53. So that's a total of 132 out of how many people? Well, I have to take the people that said no, the people that said yes, and the people that didn't answer. So if I add all those up, that's out of 237. And 132 divided by 237 is approximately 50.5569, or 56%. So that would be true, that if you're older than 41, you probably don't want this new high school. So again, if that's what I thought old was, then I would say that is accurate, and that is accurate. Younger voters are not interested in building a new high school. Well, again, what does younger mean? If I think younger is the 18 to 25-year-old bracket, and it says they're not interested, that would be 14 out of a total of 75 said no. Well, if I think about that, 14 out of 75 is 0.186. So 18.6% said no. That means the rest of them said yes. So I would say this is definitely false. Younger voters are not in interest? No. Only 18.6% said no. The rest of them said yes. So again, guys, we're going to read through this together. You don't need to copy all of this down. I'll let you know when you need to copy. So smoking and asthma. Health officials in Milwaukee, Wisconsin are concerned about teenagers with asthma. People with asthma often have difficulty with normal breathing. In a local study, researchers collect data on the incidence of asthma among students enrolled in a public high school. Here's what they found. Based on the survey, the probability of randomly selecting a student at the high school having asthma is 0.193. Let's get that down. Students were also asked if at least one family member in their house smoked. The probability of randomly selecting a student having at least one family in their house member who smoked is 0.421. Let's get that down as well. So only two things to copy down there. It would be easy to calculate probabilities if the data for students had been organized into a two-way table like the one we just used. But there is no table, only probability information. One way around this is to think about what the table might have been if there'd been 1,000 students. Basically, we're going to call this a hypothetical 1,000 two-way table. What if the population was 1,000? So hypothetically speaking, if the population was 1,000, could we fill this table out? So, here's what we need. Hopefully you've copied down these probabilities. If not, that's what we need to have jotted down here. The probability of randomly selecting a student at the high school with asthma is 0.193. This probability can be used to calculate the value of one of the cells in the table. Which one is connected to that probability? Okay, so let me read it again. If you have asthma in high school, it's 0.193. So a student that has asthma totals a 0.193. Now, I'm not actually going to put 0.193 there because I'm assuming I have a hypothetical population of 1,000. So I'm going to do 0.193 times 1,000, which will get me 193. So that's what I can put in cell 3. The probability of randomly selecting a student has at least one household member who smokes is 0.421. What cell will that help me with? Okay, so let's look at it again. I have at least one household member who smokes. The probability is 0.421. So I'm not going to put 0.421 in. I'm going to figure out what that probability is. So 0.421 times 1,000 hypothetical people gets me 421. And hopefully, so I'm going to a household member that smokes, and I'm going to have a total of 421. So now our goal is to complete this two-way frequency table. So like I said, we just figured out we have 421 total here and 193 total here. This says, in addition to the previously given probabilities, a randomly selected student that has at least one household member who smokes and has asthma is 0.120. So which cell are they describing? You have asthma and a house member that smokes. So if I meet at those two, I know that's 0.120 times my hypothetical 1,000 would get me 120. Now, believe it or not, there should be enough information here to fill in the rest of the table. So let's just use common sense. I have to total 193. I have 120. 193 minus 120 gets me a total of 73. This has to total 421. I have 120. 421 minus 120 gets me 301. This column totals 1,000. I have 193. That leaves me with 807. Again, I have to total 807 this way. I have 301. If I subtract that out, I think that's 506. And now I need to total this column, and that looks like 579. So again, the hypothetical 1,000 is just to make our math easier. We're just hypothetically speaking, if there were 1,000, and those were the probabilities, this is how many people we're describing. So now these questions are really nice to answer. So based on the frequency table we just made, let's say a randomly selected student has asthma. So I'm selecting somebody with asthma, so I'm going to this line. What is the probability that at least one household member smokes? So if I have asthma and one household member that smokes, that's 120, but probability means out of the total. So it's 120 divided by 193. Now, why did I use 193? Well, so let's make sure that we're okay with the 120. Has asthma and smokes meets at 120. Now, I'm selecting a student that has asthma, so that's why I'm using the asthma as my total number line. So if I take that 120 and divide by 193, remember I can leave it as that fraction, or I could say that's 0.6217, or I could say that's 62.17%. Part B, a randomly selected student does not have asthma. So I do not have asthma. That's a total of 807. What is the probability that this student has at least one household member that smokes? So I do not have asthma, but a household member that smokes. So I would say that's 301 out of 807. Again, if I divide those two, I'm going to say that's 0.373, or 37.3%. So part C, I'm randomly selecting a student who has at least one household member who smokes. So here's the one household member that smokes line. So I know I have a total of 421. Now here's the question. What is the probability that the student has asthma? So in my household member that smokes, that has asthma, I would say that's 120 out of a total of 421. If I divide those, that's 0.285 or 28.5%. Well, hopefully that does it tonight, and that was just a quick introduction to two-way frequency tables. We look forward to some great practice tomorrow. Have a great night.